Hello everyone, welcome back to the Histo-PathGuy. And today we're looking at one of the most important organs in the body, the liver. By the end of this video, you'll be able to identify the normal microscopic structure of the liver, understand the classical liver lobule, explain 3 hepatic zones, predict which diseases and injuries affect each zone. Now let's begin. The liver is organized into classical hepatic lobules, which are roughly hexagonal. And let me just drive down to higher power to show you a lobule. So at the center is a central vein, and then periphery it makes almost a hexagonal structure. Let me just draw it out for you if you can see them. So in the center there is a central vein, and around it forms this hexagonal like structure there. Okay, something like that. And then in the center here we have a central vein. Oh, sorry about that. Yeah, central vein. At each corner of a lobule is a portal tract, which is what I've drawn. So each corner there has a portal tract, and it's what we call a portal triad. And a portal triad consists of portal vein, hepatic artery, and bile duct. Let me just zoom in, go in at higher power to show you. So this is a bile duct here, which is lined by simple cuboid epithelium. And then there should be a portal artery and portal vein. So this is a portal vein and a portal artery is there. And here's another bile duct, vein, artery. If you come here again, bile duct, artery, vein. You come here, another bile duct, vein, artery. You remember this is a vein because it's easily compressible. Just like that. And then around here we have a central vein. Okay, so the liver is made up of hepatocytes, which are large polygonal cells with abundant eosinophilic cytoplasm. As you can see, these are hepatocytes here, and are arranged in plates that are usually 1 cell thick. These plates, they radiate from the central vein like spokes of a bicycle. As you can see, this is the central vein here, and they just radiate out like that. And between these plates are vascular channels or sinusoids, and they are lined by fenestrated endothelial cells, allowing plasma to freely move between blood and hepatocytes. Inside the sinusoids are Kupffer cells, which are resident macrophages of the liver. Their role is to remove bacteria and damaged red blood cells and cellular debris. I'm sure you've heard of something called the space of this. It's just between the sinusoidal endothelium and hepatocytes. And this is where exchange of nutrients, oxygen, proteins, and waste products occurs. Within this space, the hepatic stellate cells, also known as Ito cells, are found. These cells normally store vitamin A, if you can remember. If you just remember to refer to your normal histology text. So now the blood flow through the liver. This is where it actually just gets interesting. So understanding the blood flow in the liver is actually essential to understanding how disease affects this organ, right? So bile flow first is in the opposite direction, and so bile flows opposite from central vein to this direction, but arterial flow is from the portal triad towards the central vein. And there is what we call 3 zones in the liver towards the central artery. So picking that artery, like here, let me show you. So we have closest to that area is, oh my goodness, sorry about this. It's not, uh, it's not, it's not working. Let me just pick a different two. So closest to the central vein, we have, ooh, what am I picking? Yeah, closest to the central vein, we have zone 1, and then we have another zone which is between zone 2 and in zone 1 and 2, 3, which is zone 2. And then closest to the central vein, we have what we call zone 3. So this is zone 1, this is zone 2, and zone 3. So now with these zones, right, the zone closest to the portal artery consists of highly oxygenated blood, but nutrient poor blood. But the zone closest to the central vein is oxygen poor but rich in nutrients. Okay. Now, these zones are actually important in understanding disease, in that zone 1 is more prone to viral hepatitis, chronic inflammatory disease, and phosphorus poisoning, while the mid zone is more commonly prone to it's more affected by yellow fever, which produces a mid-zonal necrosis. So this area becomes necrotic. While zone 3, which has the highest concentration of the cytochrome P450 enzyme, which is very, very important even in pharmacology, and actually results in it's actually more, so it's more prone to acetaminophen or paracetamol toxicity. So its face gets damaged more by toxins like carbon tetrachloride and paracetamol or acetaminophen. And it's actually more prone to ischemia. So in situations where there is congestive cardiac failure, this area gets necrosed. So it's what we call central lobular necrosis. So remember, picking from here, your zone 1, 2, and then 3, this area actually gets centrally necrosed in congestive heart failure. So again, if I come in this area, I'm sure now you can make out a hepatic lobule if I went down and look first for a central vein, and then you can actually make out a nice hepatic lobule. And they remember the hepatic sinusoids radiate from the central vein like the way they are here. And you can actually make out a lobule here. Here's a lobule there. That's a lobule. You can also make out another lobule here, like that. Oops, sorry, like that. Here's a nice lobule. If I can draw this out for you so that you can see. It's not going to be perfect, but at least you get something there done. And even in the places that I've drawn, if we go to high power, you can see there's something like an artery, portal vein, and duct. And you look for a nice clear one. I think I was drawing in a weird place. I'm sorry. So this is human liver. It's not as nice as it comes out in a chimpanzee liver, like the way it is in a textbook. But I think here's another nice place where I can draw in. I can just show you. Yeah. Sorry, don't pick from there. There. Something like that there. Yeah. Something like that. And if we go to higher power, we can see something like about that there. Vein and artery there. And even we go this side, we can still see the same, yeah. bile duct, artery, and vein. Bile duct, you can see an artery, but you can see a vein. And sometimes you want to be able to see all three of them in one nice place because of the way these specimens are cut. So it's not as perfect as it seems in a textbook, but I think this is the closest one to almost perfect in identifying a hepatic lobule. So this is just a high-yield summary that I can leave you with just concerning these zones. Just remember that zone 1, highest oxygen, first to be exposed to blood from portal vein, and first to be affected by viral hepatitis. Remember, zone 1 is where the portal artery is, so it's oxygen rich. And then the mid zone, zone 2, is classically affected by yellow fever. And zone 3, highest content of cytochrome P450, and is affected by ischemia and toxic drugs like acetaminophen. So there's a favorite exam question, which is, which zone is most probably affected by ischemia? Remember, it's the central lobular zone, this area, zone 3, the area which is around the central vein. And I hope now you can at least, I can leave you something with some knowledge of knowing at least simple architecture of the liver. Remember, it's got these hepatic lobules, central vein, bile duct, bile artery, bile duct, portal artery, and vein, the hepatic artery and hepatic vein. This is central vein, it's portal vein. Yeah, fairly easy organ to remember. Very, very easy. And it's nice to look at. It's very nice structure. And actually, even it's also prone to what we call hepatic fatty liver disease, which may be alcohol-induced or non-alcoholic. But in this liver, we don't get to see that. This is fairly normal, just normal histology for a nice liver like this. And I hope you get this organ right if you are given this fairly simple organ in a histology exam. Thank you very much.